Recording is on.
Hello everyone. Hello everyone. Welcome to Accelerated Primitive Renderers. It's a current thing to talk about, and I'm actively developing on for a pretty long time. And I already held a talk about it at the last LibreOffice conference. You can refer to that video. It was about especially the Cairo SCPR. I will talk about that one, of course, here too, but I wanted to make it a little bit more general. So, why SCPR, which stands for System Dependent Primitive Renderer? Of course, to render faster. So, ADFuse got rendered by VCL output device a long time, does a lot of conversions, multiple layers, grown version of an old design. Don't forget, at the real beginning, it was just a Windows version, and you can see it because the API of output device still has this big parts of Windows GDI with brushes and pens and all that stuff. And it also is limited because of that. Due to having no alpha at that time and all that stuff. So people who did that did their best, and at that time it was state of the art, but today they would do it completely different, of course. So output device is just not capable of rendering complex stuff until today. So we are a little bit stuck there because the whole office is implemented against the output device API, and that's a problem. So what does system dependent mean? It means you can use any system specific stuff on one system. Graphic systems, for example, Cairo were available direct to D on Windows, but not limited to. You could also do the primitive renderers for HTML5, direct mode, SVG, PDF, whatever. So you can use any tech you want because you are in an isolated piece of code and do compromises for speed as you want. You don't have to, but you could. So what does primitive renderer mean? It's the primitive architecture is based on primitives and a primitive processor. Primitive processor is the more general form, and specialized primitive processor which renders primitives is called primitive renderer. So it can render any sequence of primitives you throw at it. It needs to be feature complete, and to be that, you need to support 4 base primitives and 5 group primitives. I will talk about a little bit more. With those 9 primitives, it can render all geometry defined by primitives which you could ever throw at it. So the 4 base primitives are a bitmap point array just for single pixels, but single pixel is not effective, so it's done as a point array. For example, used for grid visualization. Polygon hairline and polygon color. So the group primitives means that you can embed any sequence of primitives to them as a content. For example, to make something transparent, you put your geometry content into a transparency primitive. We also have invert primitive, which is there because of old stuff where we still use XOR stuff. That's the most dangerous and bad one because it needs read access to the target bitmap, which actual graphic systems continuously start to deny because of performance stuff, and which is bad in general. So we try to get away from XOR, and we still have some pieces where it's used, but it's getting less and less, and hopefully one day we'll have that removed completely. So mask primitive is clear. You can mask your content with polygon, modified color. That's an interesting thing with a modified color stack where you can modify the colors of any content. For example, if you have a draw shape and the shadow is created, by embedding the same geometry which is ref counted, so it's not taking more space, into a modified color with the target color of the shadow. And additionally, to the next one, the transform primitive to realize the shadow offset. So the transforms are fully linear algebra, a full transform set supporting. That's another big difference to output device. You all know map mode, and map mode is more or less linear transformations for poor guys. So it's limited to translation and positive scale. I say positive scale because negative scale is necessary if you want to mirror your stuff. Up to today, if you mirror a draw shape, actually the geometry is mirrored, which is a shame. I changed it once in AW80, but it did not make it to the master because of this interruption with all of us getting fired. So you may say there's no text primitive in these 9 basic primitives. Yeah, it's indeed not urgently necessary because the primitives support something called decompose. So primitive renderer is principally, in principle, a huge switch case. I mentioned the 9 primitives which are mandatory to make it feature complete. If a primitive is not supported, the default case of that switch continues with the decomposition fetched from the unknown primitive. This allows that you can write or add any kind of primitives as long as you provide a decompose implementation. And all existing renderers can render your new primitive. So that avoids the problems you may all know from meta files, where when you would add a meta file action, which is nearly undoable, you have to implement it in 50 places or more. It just has to be handled somehow. So all primitives except the 9 basic ones have that functionality. So you can, of course, support any number of additional primitives in SCPR. Just some examples. Polygon stroke is for patterned lines, fill gradient. We have new stuff like polygon alpha gradient. And that's another big advantage of the primitives. This was not added at the beginning, but I could add this now, and this alpha gradient primitive just decomposes to a fill gradient primitive embedded to a transference primitive. So all the old stuff keeps compatible and does not have to be touched. Same with bitmap alpha primitive, polygon RGBA primitive, and there you have the text primitive. And I also added for Cairo SCPR, for example, the SVG gradient primitives directly. We have them for a longer time, but up to now they were rendered using the decompose, and the decompose is of course slower and has to use overlapping colored polygons. Primitive decompose. What happens if you do not support text primitive directly? To keep at the example, so it gets decomposed to a sequence of polygons and gets rendered as anti-aliased polygons. Looks not bad, but we can do better. So of course it's much better to support it, but it's not necessary for a prototype SDPR on a target system. That's a good point. So all FX decorations are also offered as decompose. That was a lot of work, but it's there. Another example, glow effect. You all know the added glow effect, and all you need to do is you can use any geometry and embed it to a glow effect group primitive, and it will get the glow effect. So in the beginning, it was just used for some graphic stuff, but it was added to text too, and the only thing which had to be done was to embed the text primitives to the glow primitive, and it could be rendered everywhere where primitives are rendered. That's how it works. Primitive hierarchies. I think some people are irritated with the primitive hierarchies because there are two different ones. The one is how you organize your primitives when you create them, normally in a sequence of primitives, but when your sequence gets too big, you can anytime embed them in a group primitive to make smaller portions, and instead of a linear sequence of primitives, you can build a tree-like structure. It makes no difference for the renderer because a group primitive gets just decomposed to its content. So this is just an organizing possibility. So the sequence of primitives does not have to get long and ugly if you plan to do it in the right way. So the decomposition again can be seen as a second hierarchy. You can see it as a two-dimensional construct if you want. And so, as I said, group primitive just decomposes to content. Transform primitive, for example, embeds the stuff to edit transformations, so you can show the same content transformed in different forms, as I explained with shadow. So another motivation, the idea with primitives always was render using the base processor. This is the base class for a primitive processor, the common method to process primitives. And as you see in the names, there's always this 2D edit. This is because the same stack of software is existing for 3D, and our 3D renderer, which has a fallback software 3D renderer, uses the same technique. And so theoretically, we have not done that yet on any system. Theoretically, you can also do a SCPR for directly supporting 3D renderings. We should do that in the future, definitely. It's all prepared. So a base processor 2D, which does rendering, is called renderer. Look for derivations. We currently have 9 of them. And it's not only used for rendering, because you can also use primitives as they are currently in the office for the hit test, for example. This excludes problems with different geometries used for hit test and visualization. And for example, the sequence of primitives you can get from a draw object is also used for calculating the invalidation rectangle. And don't forget, when an object gets changed, you need 2 of them, from the invalidation rectangle before and after the change. And both need to be correct. And don't ask in what state the redraws were before I did that primitive stuff. We had constantly errors with repaint and refreshes of screen, and you had to fix weekly bugs because it was not correct. And this is completely gone since primitives. It just works. Lots of existing and possible processors, not only rendering, as I said. There are also processors, for example, to extract the animation data from the primitives, which is also embedded in the primitives. You can use a processor to filter for any stuff if you only want to extract the text from a primitive sequence you have extracted from a draw object and stuff like that. There are many more possibilities for the future. So let's get to one of the existing ones because it's the best example, Cairo SCPR. So there's also a pixel processor for Windows, which I made as a prototype for Direct2D. It's feature complete, but it's not in production state. So it was just a prototype for proof of concept. So the goal is to no longer use VCL output device and conversion backends render system dependent directly. And this is not for the whole office, but for the edit views. I strongly recommend in the future to think about edit views and the rest being separated. So I see a good future for VCL and output device and the Windows stuff as a framework. And we are going in that direction anyways with all the gluing stuff col.la has done to support different UIs and buttons and dialogues and whatever. And also the Wasm version is going in that direction to use a different UI. The important thing is to have good rendering for the edit views, and that's what the SCPRs are intended for. So some people asked me years ago, why do you convert all that data into primitives and then in the VCL pixel processor, it gets all converted back and thrown at output device? That's a good question. And the answer is pretty simple. The pixel processor was an in-between solution as a prototype fallback for the transition to primitives at that time, because we were only able to change stuff to primitives having a renderer, and the easiest way at the time to have a renderer for the in-between state was to use output device. But the long-term goal is, of course, to get rid of that pixel processor using VCL. So Cairo SCPR, col.la made an early experiment cloning that prototype for Direct2D I did, roughly adapting to Cairo, and I then grabbed that and drove it forward to product quality. So if you want to see the changes, you can just grab for Cairo SCPR, which I always used in the commit comments, like TDF hashtag to make it grabbable. So the renderer is isolated in mainly one file. There's also a tooling file for things which can be used for other renderers, which are commonly useful. It has just something like 3,800 lines. Sounds bad from the design, but in this case, it's by purpose to have it in one file, because this file is, of course, only compiled and linked if dev says that Cairo is supported. So for other renderers, similar complexity can be expected. So it's also a good test to have an idea what work is necessary to do one. So Cairo SCPR in product quality has reached product quality, is activated in master for some time. There's a meta bug to get hands on the regressions. They are pretty much all fixed. I'm currently doing one for high resolution stuff. The problem there is that the high resolution and color mapping is done in the renderer, which I think is in general not a good idea. It should be done from the geometry creating step, for example, the step which creates the primitives, or the paint method itself before painting, because doing it in the renderer means we have to do it in all renderers in the future. But I do that now in Cairo SCPR because I did not find a good way to do it like I just described. And it's just hard and much more work than doing it in the renderer. So on this point, I just give up and make it and will do it in the Cairo SCPR. So if you find a bug, because it's active in the master, please file a bug and inform me. And feedback is essential for quality. We all know that. And there's a demo collection with infos, test files, and videos showing differences, and you can look at the README there. So I did speed tests, and for them I use a pro version with 2 identical instances on the same machine, same Cairo, same hardware. And one is with the black theme and one is with the white theme. So The Cairo one is a black, and the Cairo backend, the old using VCL is black, and the new one is with a normal white theme. So showing something says more than words. So let's look on an example. So I recorded that a while ago, but you can see I'm copy pasting the same amount of linear gradient stuff, and these are the gradients which you see imported from Microsoft files. And you see the new version with white is much faster. And remember, on the same system, same hardware, same Cairo. It's just the difference between using VCL and a backend and using Cairo SCPR. So you can imagine what differences we could achieve when we would do a Skia SCPR, which we don't have. We only have a Skia backend currently. So back to presentation. So there are two classes of achievements: faster but not multiple times. Cases that were already optimized because a lot of time was already spent in the backends. And some stuff was already fast, but SCPR is still faster. And this could never get more complicated stuff faster because the definitions are just not there in the backends. And since the whole office is implemented against the output device API, it will not get there without a lot of work. Practically undoable. So cases multiple times faster. So cases where not only the setup is reduced, but also something can directly use Cairo rendering. And that's, for example, you just have seen, for example, the gradients. So to make that clear, we have another concept of transparency in the core. So what we do is we have RGB geometry, and we can combine it with two kinds of transparency. One fixed transparency, and one with any transparency you want, also defined with primitives, which are then reduced to luminosity to represent the transparency. So we are much more capable of doing things than Microsoft with just the gradients, and each gradient step does have an alpha. So we can theoretically mix any output with any transparency, but of course it's not that useful because it's not really used except for gradients. So normally the definitions of the RGB gradient and the grayscale gradient are the same, and it's just left over from the old days too. But nowadays we can fix that and merge it at the right spot when creating the primitives, and the primitive renderer can just render RGBA gradient, what you have seen in the speed example. So that's what you saw. It's all got alt ones. Other achievements. There are many cases that are much faster as a bonus direct support for SVG gradients. Want to show that too. No, that's the wrong. That's also interesting because with the SVG gradients, we also had the problem I already talked about, that this is pretty slow. So you see, this is the VCL backend with the decomposed SVG gradient, and this is the new version directly supporting the SVG gradient. So that makes the difference, and we can do the same for other target graphic systems in the future. And I strongly recommend to do that and to continue that. So now it gets copied a few times and then it gets completely blocked, as you all know. But let's get back to the presentation. You can watch those in the from the example link I offered. So you can watch the videos, but it's simple to play around with it yourself. You just need two versions or one version. Use the Pro version to have not influence from debug code. And you can deactivate Cairo SCPR anytime with the environment variable, which is mentioned here. And this is very handy for one to play around with it, and for the other, much more important for bug hunting. And that's always the first thing I tell people when they think it may be a Cairo SCPR error. Disable it and check if it still happens. If it does not happen, then it's indeed a Cairo SCPR error. So there's even a simple way to check that. So general drawing, all examples from the test file can be combined with fx. So I have this test file from which I took the examples just to show, and text, for example, with all the possibilities, all rendered now using Cairo SCPR. Back to the presentation. So I'm not aware of the single case where Cairo SCPR is not faster than using Cairo in the backend. So the gain depends on what is needed to be done, of course, and text is slightly faster, was already fast, thanks to the stuff Quaylen did. Fat line drawing, for example. It's much faster with Cairo because luckily Cairo uses the same line tessellation which we have. So if you don't know, we have a full stack for the decomposition of fat lines to the minimal 9 primitives I mentioned, which does the whole tessellation, which is capable of doing the whole tessellation. The other one is not so important. There's one strange mode. Render quality. Rendering is not just faster, the quality is also improved. For gradients, of course, because no more decomposition is needed for overlapping single colored polygons. So for pattern fill, it's much smoother and no more limits on how small the tiles can be. And for SVG, as you have seen, gradients are supported directly. This makes a big difference. So the future, we can still extend Cairo XCPR. I have added a lot of primitive support beyond the 9 minimal ones. We could still add something for glow, soft edge, shadow blur, whatever. It's not in there, but still pretty fast because it also gets buffered with the primitive mechanisms. And if you see something that is not fast enough, it's always possible as an option to add support for that primitive or what the primitive needs and the slow part in an existing SCPR. So after this 9 required primitives are supported, you can add what is needed and you don't have to add everything like in the meta file stuff where you have to support all existing meta file actions. So make things much more easy, and you can think about what to support and what pace to support and what is really slow. So Windows Direct 2D support, we may continue to do that. For Mac, I have no idea. I'm not a Mac guy. There is, let's talk about Skia. Of course, we can do a Skia SCPR, and the API is even pretty similar to modern graphic system, so it would not be too different from Cairo SDPR. And we would have the advantage to have a Cairo SCPR renderer for all target systems, and this would allow to do much deeper changes in the code. And output, there's also another possibility to replace VCL stuff. I did 2 prototypes, and you can find talks about it. One was at FOSDEM and one was at another LibreOffice conference where I did prototypes to forward calls from VCL to an existing SCPR, and this would allow to let output devices run without the backends and only using SCPR if one exists for the system. And I did that for Rectangle as an example. In those both things, you can also find the commits on Gerrit if you want to play around with it. And it just works. It draws the whole office, including, of course, then the dialogues and the button bars and whatever, using the SCPR, but only in this state of progress for rectangle. So filled rectangle and hairline rectangle. To make it visible, I added the created primitives to a color modifier primitive group to make them randomly a little bit shiny red. So you can live see it if you apply those patches, which parts of the screen are rendered by this redirection. It's pretty funny to watch. So output device in general could be used as a paint forwarder. This would also be useful, for example, to isolate the meta file generation from output device. This should get separated one day, and also to separate the PDFX outdef data mayhem. This could also just be done in a paint forwarder. But this is future stuff, and not sure if this is worth doing. So example for other benefits. One of my changes was enhancing convert to bitmap X, which is used from many places, also from Juno API, and can do that now directly because Cairo SCPR has also a constructor for the renderer to create a new Cairo surface and directly render to it in RGBA. And there's an extract bitmap X from base processor 2D to get back the result to use it if you want. So this is not just for Cairo SCPR, but would be useful for any future SCPRs. And that's why I mentioned to do eventually a Skia SCPR, because when we have SCPRs for all systems, I could apply stuff like that to much more parts of the office. And so doing that directly with RGB A is maybe 3 times faster felt, not measured. So we really should go forward in that direction. There are a lot of potential to use. So that's it from my side. If you have questions, go ahead.
Okay, thank you, Armin.
Well, can I jump in, Anna?
Yes,
I'm always greedy for questions. You know? Nice talk, Armin. Brilliant. Good to see you again. One of the things I really love was your test documents there. You have a lush set of beautiful documents that cover the surface there. Are those all in Git somewhere? And I assume our QA people would love to play with them.
Yeah, it's on the share, and I already moved it to the Collabora share. I can send you a link.
Great.
There are also see animations showing the difference.
Wonderful. It would be nice to get Anna's team some of those, I think, for impress testing and things. But no, looking really good.
So, and I have another one. If any of you do something with graphics in the future, please use primitives. Everything else will be a waste of time, and we will have to convert it to primitives later. More questions?
Okay. Thank you, Armin. I think Michael finished. Yes. Balazs, questions?
No question from me. Thank you, Armin.
Kellen?
It occurred to me that VCL does various kind of tricks, and one thing that I just was reminded of is if you have numbers in your text and then the language is set and some other features set, it will replace the numbers with numbers from different scripts. Does that kind of thing still work with the Cairo SDR? Is that handled someplace automatically, or is that something that hasn't been?
If you have something in mind, just test it with the method I described with the environment variable, but I think it does because the edit engine, for example, is currently a hybrid, and it can paint directly with the old stuff, and it's also capable of creating a sequence of primitives representing the text, including everything like redlining and whatever. And I'm currently working on expanding that to make edit engine completely relying on primitives anyway, so we will see. If something comes up, it comes up and has to be fixed. Currently it's really a mayhem, because if you have to do changes to edit engine, you have to do it to both creators of geometry, and that's a big waste of resources. So I'm doing that. The second background is this will allow in the midterm to buffer the text rendering, for example, of calc, which is very expensive because it creates an edit engine or reuses one. It makes no big difference. The creation is not the part which takes a lot of resources, but it needs to be set up, and then the text is set, and then it's layouted, and then it's formatted, and then it's rendered, and then it goes through VCL, and then it goes through the 3, 4, 5 layers of VCL, and then it comes to the backend. So if the edit engine is capable in the future to just create primitives, I can buffer it at that stage and prevent the first part of this always formatting, as long as the cell is not changed, and prevent the back part with the VCL backends by just using Cairo SCPR. That's the plan, for example.
Yeah, sounds very good.
Thank you, Kellen. Geber, Gogai, questions?
No questions. Thank you. No question.
Thank you. Jaume, Joao, questions?
No questions. Thank you.
Jaume? Okay. Mevan?
Yes, I'd be curious. So you mentioned Skia. So I think if we were to have a SDPR on WASM, I'm guessing we will need also the Skia SDPR, because it exists already, Skia for WASM. What would you think?
Yeah, I urgently think we should do Skia SCPR, not because I think Skia is perfect, but it would allow us to have an SCPR on all target systems. And when we achieve that state, we can just do much more using the existing SCPRs, as I showed in this one example, convert to bitmap X. So this would be very handy. Of course, Skia is also using just the graphic systems on different systems, so it cannot be faster as the graphic system it's using. So I think in the back of my head, directly supporting a target graphic system cannot be slower as Skia, it can just be faster. But that's just me.
Yeah, and another question. Do you have some testing to just test the rendering? Well, I'm guessing it's very easy to do, or you don't need to do like automatic bitmap comparisons or things like that to ensure the quality of any same implementation.
Yeah,
The
not
yeah.
really. The basic test is you will not believe how many tests popped up when I was doing all that, and we have already message tests which will complain about you that the wrong color is at the wrong pixel and stuff like that. And this needed a lot of work, but also, as shown here, is a necessary thing and made Cairo SCPR definitely much better. So
All right.
it's a pain and a help.
But for correctness, it's important. Thank you.
Welcome.
Thank you, Melvin. Next, I have Mike Gagansky Mohit questions.
Yes, I had a question. Thank you, Armin, first of all. Yes, I understand that these are system dependent, and so Skia could be just intermediate level between this, and so could slow down, but it has an upside of unifying and relying on less differences. So, what real downside would be in using Skia also on Linux as a backend? And I mean, downside in numbers. Is it really slower than using Cairo directly?
I have no idea. You're right. As I said and also proposed, it would be a good solution to have SCPR on all systems. And why not on Linux too? It's also correct. I can have only numbers if we do it.
I see. Thank you. Reasonable.
Okay, thank you, Mohit. No question. Michael Stoll.
Yes, so you said that the Cairo SDPR is almost 4,000 lines of code. Do you have an idea how that compares to the size of the output device platform-specific backend code for Cairo? Like, is it bigger, smaller?
It should be pretty much the same size, I guess. Of course, I also looked at that code to get some suggestions how, for example, to get read access and all that stuff. So it's pretty much the same size. And to mention it, there's also an idea to write a Cairo, not a Cairo, a general SCPR is not only possible with using Skia, it would also be possible to do one which uses the existing backends directly, just to mention that. But it would be limited to what the backends really are capable of doing. So I do not seriously suppose that.
I just did a quick measurement, and it seems to be exactly 3,000 lines for Cairo stuff as well. Or maybe I'm missing something.
Yeah, that was my guess. Yeah, should be pretty much the same size.
It depends whether you're counting semicolons or not. I was counting raw lines, but.
So in principle, you can see it as a modern replacement for backends, which is capable of rendering complex linear algebra-based graphic definitions. And I mentioned in the talk that one of the problems is that the whole office is implemented against the API of output device. And one way, and the best way in my point of view to avoid that, is to use something like primitives. So you do not paint directly, you define geometry and throw it as a renderer. and the renderer can do then the best it can on the system it's running at. This avoids to run this gap again, from my point of view. And it's also a source for hit test, for bound rect, for PDF export in the future, for printing, for whatever. So, and you always have the guarantee that it's the same geometry because you don't have a paint where you have to do something like if PDF X out dev data and if meta file active or whatever, and you do different things and you end in chaos. That was the state before I did the primitives. Be warned, it leads to chaos. I've seen it.
Okay, thank you. Next, Noel, questions?
No questions, just happy to see progress.
Neil, questions? Okay, part questions? Sarper and Skylar questions?
No questions. Thank you very much.
Okay, I guess that's all. Thank you everyone for joining. See you next time and bye-bye.
Thanks all. Bye.